we'd like to take y plus 2 over y minus 7 and subtract 3 minus y over 49 minus y squared. To do that, as always, we'd like to factor both the denominators. So y plus 2 over, well, y minus 7 is prime, it doesn't factor, minus the quantity 3 minus y over, here, how does that's the difference of two squares. Is it 7 minus y times 7 plus y? Once again, as we did when we were simplifying rational expressions, this will be a lot easier if we notice that when we start to try to find the LCD, if we write down the first one, y minus 7, and start examining the second one, certainly we need 7 plus y, but I can write that as y plus 7 since it's a sum and it's commutative. But what about the other factor, 7 minus y? This factor. We said that's the opposite of 7 minus y is the opposite of y minus 7. So instead of trying to take three factors as the LCD, what we'd always do is substitute at this point, we'd substitute in for one of them the opposite of its opposite. That's a funny way to say it, but let's replace 7 minus y by its equivalent, which is the opposite of y minus 7. So before we do anything else, we are going to take care of this fact that we have opposites as factors of the denominators. So we start with y plus 2 over y minus 7, and we've decided, and then that's minus 3 minus y, and we've decided let's replace 7 minus y, which it's with its equivalent, the opposite of y minus 7. And then we still have the, I'm changing this to y plus 7 since that's the same thing as 7 plus y. Well, notice here, we're going to do one more thing. That negative in the denominator we don't want as part of our LCD. Look up over here to the right. This is what we think our LCD can really be, because y minus 7 and y plus 7 are really the only factors in the denominator. We just have to get rid of that negative sign. And like any fraction, if I have 2 over minus 3, I can write that out in front as minus 2/3. So I will put that, we're going to move that negative up and change this to a sum. We're going to say this is y plus 2 over y minus 7 plus 3 minus y over y minus 7 times y plus 7. We've now successfully changed this so that this LCD up over here in the right corner, y minus 7 times y plus 7, is the LCD of this sum of rational expressions. And now we just continue as we've done before. We already have the LCD in the second term. We just need to get it in the first term. So y plus 2 over y minus 7. Multiply that by 1 in the form of, what do we need? Y plus 7 over y plus 7 plus 3 minus y over the LCD of y minus 7 times y plus 7. We have to multiply out this numerator. Let's see, that's remember this quotient here, y plus 2 over y minus 7. That's really a single term, which means when we're multiplying that has to distribute. We get y squared plus 7y plus 2y plus 14 over y minus 7 times y plus 7 plus 3 minus y over y minus 7 times y plus 7. Combining like terms on the left side, we get this is equal to y squared plus 9y plus 14 over the y minus 7 times y plus 7 plus 3 minus y over y minus 7 times y plus 7. This is an addition problem, so all we have to do is combine like terms. We just have to add up the numerators. What does that give us? Y squared, we have 9y minus y is plus 8y, and then 14 plus 3 is plus 17 over the y minus 7 times y plus 7. Now we, as always, we're going to see if it simplifies, but two numbers that multiply together to give me 17 and add together to give me 8 don't exist, so we are done. That is, we have now done the original subtraction problem. Note here what we did. We went through and we noticed there were opposites in the denominators, that y minus 7 and 7 minus y were opposites, so we replaced one of them by the opposite of its opposite, and then we moved the negative sign up and turned the subtraction problem into an addition problem. That allowed us just to then continue with a simple LCD and add the two expressions.